Great. Yeah, I was saying that I'm one of the cryptographers in Humanode, and we're a team that are building what Victor called the version 2 in biometrics, because right now we are using some kind of centralized version for the authentication system using the enclave from FaceTech. But the idea is to have decentralization in every layer of the system. So this is what we are going to talk right now. So what we want to achieve here is first of all, guarantee the privacy of the users. That traducing that the image, the faces don't leave the device ever. So once you take the image for the authentication and registration, that image it stays with you. Also get proof, and when we say here proof, we are talking about cryptographic proof that the operations are done correctly without any manipulations. Also, we want to have resistance to different attacks, like for example, civil attacks and replay attack. And one central point here is that we don't want any central entity to manage the registration and authentication. So there is a fancy way we call collective authority that will take care of this. And when we compare the feature vector, and feature vector, you know that it's the output of the neural network. And this feature vector is in a unique way linked to the image. So we want to compare it without decrypting it. And also we are building two kinds of decentralization. And decentralization of the data, so we don't have any central database. And also the centralization of the computations for the cryptography, for the cryptographic schemes. And in a very high level, this is how we are doing this in Humanode. We are taking first the image and making the liveness detection so that it is a real person that it is in front of the device. And this is in line what Victor was describing in liveness detection. But in version 2, we will have zero knowledge proof of the liveness detection, not only the proof of the output, but also the proof of the correctness in the liveness detection, in the calculations for achieving the liveness detection. Then we have a neural network, but maybe some of you know that neural network works in layers. So those layers are going to be protected, or we're getting the proof of the correctness of the calculations in every layer of the neural network. And this is done using zero knowledge proof, Gamal crypto system, and the neural network itself. And finally, after we get the output of the neural network, we want to encrypt this feature vector and store it for every time the user wants to authenticate. And we want to compare the two vectors, the original one for the registration that is stored, but also with the vector, the encrypted vector that it's generated every time the user is going to authenticate. So we are having here a lattice-based scheme with homomorphic properties, so we can make the calculations without decrypting the filter vector. And final words about the collective authority will be at the end. So let's begin into the details about how this works. First of all, the liveness detection, and in his passive mode has this texture and local shape analysis, the distortion and edge analysis. So this is the liveness detection in general, but what I want to bring here is that for every calculation or every stage of this analysis, we are going to build a zero knowledge proof for every analysis that it's been done. So we don't have any, just the output that their face is real or not, but also we need to make a proof of this. And maybe you wonder why we need to do that, why we need to complicate things here and not just having the liveness detection. And that's because this is done decentralized in a decentralized way. Maybe one node can fool the liveness detection, despite the fact that the liveness detection will be one of the best out there. It is still the chance that they can fool the system. So we need to make sure in every front. And that's why we are going to build the zero knowledge proof for this also. Then the private neural network, as I was saying, this is a system for getting the proof of the correctness in every layer of the neural network. So we can say that the neural network is run correctly, because as you heard before with Victor, this neural network will be run in the device of the user. So we don't want the user manipulate the system, and we need to get the proof of this also. Well, more in detail, the Feldman non-interactive verifiable secret sharing, it's work this way. There is a mathematical concept that is called isomorphism. We can have an isomorphism between the vector and a polynomial. If we take the members of the polynomials, the coefficients of the polynomial can be isomorphically mapped to a vector. So we can take the vector and turn it into a polynomial. And this verifiable secret sharing let us check the validity of the share by verifying this equation at the end. Also, we have the ElGamal crypto system that for those of you that knows how an encryption scheme works, this is a public key scheme. This is how it is generated. We have the key generation algorithm and encryption, etc. And you can see that the form of the ElGamal crypto system, it is in the same sense that the Feldman's verification here. Also, we have the non-interactive zero knowledge proof, where we have essentially two algorithms, one's for proving and one's for verifying. And the prover needs to generate, of course, the proof. And the verifiers run this algorithm and trying to get the output, whether the verification is correct or not. And the verifications will be run in the collective authority. We will talk later on. Next, after we have the output of the neural network, we can say that we are using an encryption scheme, BFV homomorphic crypto system, that also happens to be quantum resistant. And this decentralized version, we can say here first, this is the usual encryption algorithm where we have key generation of the form, the encryption, and the homomorphic operations. But in our case, we are defining right now a decentralized version where we have a collective key generation. And with this key, every node will encrypt the feature vector. Also, we have a key switch protocol that allows us to make the calculations in the collective authority. This is the form of the collective public key for this decentralized version of this encryption scheme. And the key switch protocol, in short, help us to get the output without needing any communication with the nodes. So it works this way. You have a bunch of nodes, and the collective authority is a subset of the Humanode network. And then every node sends his private future vector, encrypted with the collective public key. Then the collective authority re-encrypts using this key switch protocol, so he can be able to make the homomorphic operations. And then also we can say that in the collective authority, we can't link the nodes and their data. So not only we are getting a protection using the encryption scheme, but also using this key switch protocol, we can have an extra layer of security that we don't link the feature vector encrypted with the node itself once stored. And this is the final concept I want to mention today, the collective authority. As I said, this is a subgroup of the Humanode network. It is like the trusted third party for key generation. Also, it will define, it is there where the parameters for the cryptographic protocols are defined in a setup algorithm that is run at the beginning of the network interaction. So basically that's it. So in summary, I want to say that we have three stages in the crypto biometric right now: the liveness detection, the private neural network, and the encryption scheme for storing and matching the cryptographic, the feature vector. And the matching algorithm, it is done thanks to the homomorphic operations and the homomorphic properties of the encryption scheme we are defining. And I say we are defining because we are using a new decentralized way of seeing this encryption scheme, not in a traditional way. Some of you may know that every public key encryption scheme needs this central authority, this like public key infrastructure, and the collective authority that will be the nodes itself, a bunch of nodes itself in the network, will have this this task for managing the key generation and all that. So we are getting here a fully decentralized biometric system that it is not, as far as I know, it is completely new right now. And I would like to hear any question if anyone has.